Now let us discuss the free vibration. The first topic of our discussion in the vibration is your free vibration. Free vibration means we are considering in this case that there should not be any friction present. We are neglecting the friction, right? So in the free vibration, if I can write, right? So in the free vibration there is no friction present in this case, and in this case there is no dynamic loading, there is no dynamic force, right? No friction and no dynamic force, and the system will, once the system will be disturbed from its initial equilibrium position, the system will oscillate on its own. There should not be any friction present, there should not be any dynamic force present. So that type of system is known as free vibration, and we are only considering the single degree of freedom system in which the only one parameter is required to define the state of the system. So before moving to the free vibration equations of the motion, then first of all let us discuss about what are the various types of systems of free vibration. So we have to discuss all of them. So let us start with the types of system. Right. Now just pay attention, we'll explain one by one. First type is your elastic restoration type. Elastic restoration type, in which, as the name suggests, in the elastic restoration, the restoration which you require so that the system will come back to its initial equilibrium position when you disturb the system, that restoration will be given because of the elastic property of the system. Elastic property of the system means, suppose we have spring. So the elastic property in the spring is the stiffness of the spring. So if that spring is present, then that type of vibrating system is your elastic restoration type of the system, right? So here the restoration will be because of the elasticity of the system or the elastic properties which are present within the system. The second type is your field restoration. Second one is your field restoration. Field restoration. As the name suggests, in this the restoration will be provided because of the field present around or surrounding to the system, right? Suppose in case of your pendulum we have gravity, suppose some electric field is there, magnetic field is there, and because of those field which is present around your system, then if the restoration will be given by those field, then that is known as field restoration type of the system, right? So we can say that in this field restoration type there is no elastic member. There is no elastic member present, right? In this we have no elastic member, and if there is no elastic member, then obviously there is no strain energy concept here. No strain energy, right? As we discussed in the case of your elastic restoration, the energy which will be required for the motion, that energy, or you can say that energy, will be stored in the strain energy of the system because of the elastic properties. So it can restore the energy. If you have the excess energy, that the system will restore the energy in the form of its strain energy, and if you require the energy for the motion, then it can give this strain energy to the system and system will continue its motion, right? Suppose you stretch a spring. So the energy which you are giving in this stretching, then that energy will be stored in the strain energy of the spring, and when you leave the spring, that strain energy will be released. So that is the strain energy concept. So if the elasticity is present, then we have the strain energy. The energy which you give will be stored in the strain energy of the system, and when you require that energy, then your spring or the elastic member will release its strain energy. But in the case of field restoration, we have no elastic member, there is no elastic member, no elasticity present, and there is no strain energy. So it is known as field restoration type of the system. So in the elastic restoration we have further two types. In the elastic restoration we have further two types. One is the your linear motion. If the motion done by the system is your linear motion, then this is this case, linear motion case, right? For example, if I draw the diagram, suppose this is a fixed surface, fixed point, there is a spring attached, and suppose this is a block, some block of mass m. Suppose this is a block of mass m, this is a spring of stiffness k, this block is placed on a surface, right? Suppose they are on this surface, right? Now if you disturb this block, then suppose you will give in this direction some displacement. This is at its equilibrium position. Now if you give the displacement, the spring will be stretched and this block of the mass m will be in this translation motion, like this. It will be in this translation motion, right? So this is your linear motion case, if the spring is linear spring, right? This is your linear motion case. Second one is your angular motion case. If the system is in under its angular motion. Second one is the angular motion case. Angular motion case. Angular motion case means in this linear motion we have linear spring. This is your linear spring. This is your linear spring. In the angular motion case, we have torsional spring, right? Suppose in this case, we have the elastic member which we have is the torsional spring, right? I hope you saw this, how this torsional spring will work. This is the torsional spring, right? Suppose if let us discuss this with the help of a diagram. Suppose we have a disc. Suppose we have a disc, and this disc is attached with a torsional spring. Torsional spring can be denoted by this, like this. It is attached with the torsional spring. And now if you give some rotation to the disc and leave it, we give some rotation to the disc, we disturb its equilibrium position and I leave it, then this spring will be like this. This spring will start rotating like this, right? This is a vibration, and that vibration is because of this torsional spring. So this is the angular motion case, right? So in the elastic restoration we have linear motion, we have angular motion. Similarly, in the field restoration we have, suppose that restoration is given by the gravity. Suppose if the restoration is given by the gravity, so we have gravity restored system, right? And suppose in this gravity will also work like two, right? For example, in this gravity, if the system is gravity controlled or gravity restored, that means the restoring force will be given by the gravity. This gravity is also of two types. This system, the system which depends upon the gravity for the restoration, those systems are also of two types. One is the linear system. Another one is the angular system. Linear system means when the motion is in the linear translation. In the linear motion and the angular motion, the system will be your rotating, right? In the linear motion, for example, if I write, suppose you want a case. Suppose we have this U-tube manometer. We already discussed the U-tube manometer in our fluid mechanics. Suppose this is a U-tube manometer in which we have some fluid here. Some fluid is filled on this, right? Now, if I push this fluid in the downward direction, and if I remove the force. I push the fluid in this direction and I remove the force, then this liquid column will be right like this. It will be in the linear motion like this, right? And this restoration will be given by the gravity, the weight of the fluid column, right? The gravity, and this is your linear system. Angular system case and restored by the gravity, we already studied the pendulum case. The pendulum case. Suppose we have a pendulum here, right? And let us say if I disturb this up to this position, if I disturb this, then it will be under rotation. About this hinged point, it will be rotation. So it will do this reciprocation. And here this fluid column will be reciprocating like this. Fluid column will be moving like this, and in this case it will be like this, right? So we have two cases: linear gravity controlled, angular gravity controlled. Another one is from the gravity, another one is your other fields, others cases like your magnetic field. Suppose the magnetic field will act as a restoring property, so that is the second case. So we have these different types of the system which is present in the free vibration. We have to discuss all of them. First of all, we'll take this linear case, right? And along with this, we'll discuss the angular motion when the torsional spring is attached. Then we have gravity and the other properties, and this we will neglect in our course. We are not concerned about this other field restoration properties. We are not considering. We will only talk about this elastic restoration and the gravity controlled restoration. Right. Now let us discuss the basic equation of motion of a free vibrating system. Free vibrating system, we already discussed that there is no damping, there is no unbalanced force, right? Or there is no dynamic force also, you can say that. Now suppose this is a basic mechanism, right? Basic model of a free vibrating system. Let us say this is your fixed point. We have a spring attached whose stiffness is K. K is the stiffness of this spring, right? And in this case, I am assuming that this spring is massless, right? We are assuming that your spring is massless. Spring is massless. Right, we are assuming this, and this spring is attached with a body. This is one object whose mass is, let us say, m. M is the mass of this body, and this is the initial equilibrium position of this body. So this body is at its equilibrium position at this condition. Equilibrium position means the spring will be at its natural length, right? The spring will be at its natural length, and there is no force acting on this body, and this will be in this equilibrium position. Now suppose if I disturbed this with from this to here. Now if I disturb this mass, if I move this mass in this direction with a distance x meter, right? Suppose this distance is x. Suppose this distance is x. We disturb the equilibrium position of this mass, and let us say in this direction we are disturbing this in this direction, right? And this is x. By x unit we displace this. Now this mass will come at this position. Suppose the mass will come at this position, right? The same mass will come at it, will make this, right? Suppose the mass will come at this position after disturbing the equilibrium position, right? Now if I make the free body diagram of this mass, right? I disturb the equilibrium position, I push this in this direction with a distance of x meter, and then I release the system because we are discussing the free vibrating system. There is no friction, there is no force acting, so I release it. Now this body will be in oscillation about this equilibrium position. This body will oscillate, and this is a free vibration, right? Now we are giving the displacement in this direction, right? So in this direction, let us say the displacement is x, and suppose the velocity which we are giving is, let us say, x dot. X dot is the velocity, and after that I release it, right? Now if I draw the free body diagram of this body, let us draw the free body diagram of this body.